Hello everyone. In today's session, we will discuss about the transfer functions. First, we'll start with the introduction. So, the transfer function plays a crucial role in computer graphics and visualization. They defines how the data is mapped to the visual properties, allowing users to explore and interpret the complex data sets. In simpler words, transfer functions serve as a mapping between the input data and the visual representation, allowing the users to convert the raw data into the meaningful images or visualization. A transfer function first takes an input data such as the scalar values like the density or the temperature or the concentration, then maps them to the corresponding optical properties like its color or opacity. Second thing to discuss is the importance of transfer functions. They hold significant importance in computer graphics and visualization. The first is the enhanced visualization. Transfer function enables users to emphasize important features, also reveal the hidden patterns and improve the overall clarity of visualization. The transfer function convey the information in a clear and intuitive manner. Second is the interactivity and exploration. They support interactive exploration of data. The users can dynamically adjust the transfer function so that the complex data can be explored. Third is the improved perception. Transfer functions can enhance the human perception of data, leading to more effective communication and decision making. They enhance the perception by emphasizing the important features and suppressing irrelevant details in the data. Defining transfer functions. The transfer functions can be defined in the three ways, which are as follow. First is the mapping data to the visual properties. As we have seen earlier, the transfer function defines the relationship between the data values and visual attributes such as the color, opacity, and size. They take the input data and then map it to its corresponding properties. Second is the multidimensional mapping. They can map multiple data dimensions simultaneously, such as the complex multivariate data sets. Third is the mathematical formulation. Formally, a transfer function can be represented as a mathematical function that transforms the data into its visual representations. Types of transfer functions. There are several types of transfer functions. Some of them are listed here. First is the 1D transfer function. These functions map a single data attribute to a visual property. Second is the 2D transfer function. This utilizes two data attributes to determine its visual properties. Third one is the multidimensional transfer function. They map the multiple data dimensions to create more complex and informative visualizations. And the fourth one is the customized, in which the users can create their own transfer functions based on their needs. Designing effective transfer functions involves several key steps to ensure they accurately represent the underlying data and effectively convey the desired information. First is understand the data, that is the data understanding. Thoroughly understand the characteristics and the properties of the data to be visualized. Second is define visualization goals. Clearly define the goals and the objectives of the visualization. Determine what insights or the information you want to convey to the viewer and how the visualization will be used to support analysis or decision making. Third is select mapping techniques. Choose appropriate mapping techniques based on the nature of the data and the visualization goals. Fourth is iterative design process. Design the transfer functions through an iterative process of experimentation and refinement. Start with the initial hypothesis or assumptions about how the data should be mapped to the visual properties and iteratively adjust the transfer function parameters based on the visual inspection and the analysis of the resulting visualization. Fifth is consider perception principles. Take into account principles of human perception, such as the color perception, contrast sensitivity, and pre-attentive processing. Design transfer functions that leverage perceptual principles to effectively encode data attributes and facilitate rapid and accurate interpretation of the visualization. Validation and evaluation. Validate the effectiveness of the transfer function through qualitative and the quantitative evaluation. Applying transfer functions in visualizations. They are used in volume rendering. In this, transfer functions are crucial for translating volumetric data into visible imagery. By assigning the color and the opacity values, transfer function enables the creation of realistic and informative renderings of 3D datasets. Second is the scalar field visualization. The transfer function highlights and emphasizes some of the specific features. Third is the multivariate visualization. It enables the exploration of complex data sets, multidimensional data sets by mapping the multiple attributes simultaneously. Challenges and limitations of transfer functions. Despite their effectiveness, transfer functions in computer graphics and visualizations comes with certain challenges and limitations. First is the complexity and the learning curve. Designing the effective transfer functions can be challenging, requiring a deep understanding of the data, perception, and the visualization techniques. Transfer functions may struggle to effectively represent the highly complex or the multidimensional data sets. Mapping high-dimensional data to the visual properties in an intuitive and meaningful way can be challenging and may require advanced techniques or simplifications. Second is the dimensionality constraints. So, higher dimensional transfer functions can be difficult to visualize and interacting with, limiting their practical application. Limited expressiveness. Some transfer function techniques have limited expressiveness in capturing the certain types of the data, variability, or relationships. Automation and generalization. Automatically generating the optical transfer functions for diverse data sets remains an active area of research and development. In conclusion, transfer functions are indispensable tools in computer graphics and visualizations, enabling the translation of the raw data into the meaningful visual representations that aid interpretation, analysis, and communication. Despite their effectiveness, transfer functions come with the various challenges and limitations, including its complexity handling, learning curve, subjectivity in design, and also the difficulty in handling the uncertainty and variability in data. The future developments as the research and technology continue to advance, we can expect to see even more sophisticated and user-friendly transfer function tools that will further enhance our ability to explore, analyze, and communicate the data. Thank you.